So this is 2.6 notes which are called rotation. So we have a couple of quick vocabulary about rotation, and then I'll show you how we're going to do a rotation with tracing paper first, and then I'll show you what we're going to do moving forward, because we're not always going to want to rely on the tracing paper. Like you saw with reflections, same thing. You can do it with tracing paper, but it's not as easy, and it's hard to always have on hand. So let's start with just a few quick definitions. So it says a rotation is a transformation in which a figure is turned about a fixed point called the center of rotation. So you're turning whatever figure you're working with a certain number of degrees, and you're keeping a point fixed as you do that. Now sometimes the point will be right on the object itself, or the figure. We're going to see eventually when we get to this example that notice there's like a point kind of floating away from it. When we use graph paper, you're going to be sometimes given a point as a coordinate. Like it could say, can you do this rotation this many degrees about point 5, 3, right? Or something like that, where it'll tell you the point, you would plot it, and then you could go from there, okay? If the center of rotation is not specified, so let's say the question doesn't say anything about what point, then you're going to imply, it's implied that 0, 0, or the origin, is the implied center of rotation. Okay, so anytime it doesn't tell us, like on the two that we're going to do today, it is going to tell us. On the homework, I believe it tells you also, but actually it does not on the homework. So both of those will be done, actually no it does, it says about the origin. So sometimes it'll tell you, just do it about the origin, but if it doesn't specify, you just automatically just do it at the origin. And I'll show you what that looks like. Okay. Then we have, in a rotation, rays drawn from the center of rotation to a point and its image form the angle of rotation. So in order to do a proper rotation, we need to know how many degrees to rotate it. And so if you think about a circle, a full circle is 360 degrees. Think of like a clock is another helpful thing. Notice the clocks that are drawn in here. Well, a clock moves usually from like 12 o'clock, then to 1, to 2, to 3, and so on. It moves clockwise. That's what it's called, when it moves from 12 o'clock to 1 o'clock to 2 o'clock and so on, all the way back until it gets back to 12. Whereas counterclockwise is the opposite direction, where it goes backwards, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then back to 12 again. So we're going to need to know the direction also, in addition to how many degrees it's moving. Now we are going to only stick to multiples of 90. That means you'll be asked about rotations that are 90 degrees, 180 degrees, 270 degrees, or back to 360 is just a full circle. So we don't have very many examples that we're going to need to do. Even with homework or on a quiz or a test, we won't ever ask you about something like 45 degrees or 20 degrees, because we're only sticking to, again, multiples of 90. You'll see why. We're going to be using our paper and like turning it physically, and we only can do that, if you think about a paper, we have only 90-degree turns that we can turn the paper at. Without using like a protractor or tracing paper, we don't want to always rely on other methods to do something else. Okay, so these clocks here show you what the angle looks like each time. Clockwise, again, goes with the numbers, increasing from 12 all the way back to 12 again. And then counterclockwise is if you went backwards or the other way. So if a direction is not specified in the problem, then you imply that you're going to go counterclockwise, which kind of seems odd maybe. I don't know why mathematicians pick counterclockwise. But again, that's only if they don't tell us the direction. If it just says, hey, can you rotate this figure 90 degrees about the origin, and it never said counterclockwise or clockwise, you would just imply, it would be implied that it's counterclockwise. So you're going to move it kind of the opposite way of a clock. Okay, so we're going to try out a quick rotation before we get to the actual examples where I'm going to show you how to do the rotation without tracing paper. Right now I just want to kind of just show you what a rotation would look like, just to practice the idea. I'm going to change where P is, kind of up here, because it doesn't fit on the paper otherwise, so that was a little mistake there. So if you happen to have your tracing paper and you want to try this out, or if you want to grab some tracing paper and try it out with me, you can. You don't have to do this. You can even just kind of freehand where the duck would go. It's just a random picture of a duck, and we want to see where it's going to end up when we do a rotation. So I started off by drawing out, or tracing, oops, I plotted this here, and I'm going to put this here. Okay, so we plot, what you're going to do is you're going to trace out, making sure your paper, your tracing paper, I would try to keep it straight, whatever way you decide, like horizontally or vertically, but try not to make it like diagonal or crooked, because it's going to be hard to figure out how many degrees then. So if it's horizontal like mine right now, I traced out my duck here, and then I also traced my letter P, which was down here. We changed it to be up here so it fits a little bit better. So what I'm going to do now is, if I keep my pen or pencil kind of fixed at that point, I can rotate my paper as it stays fixed there. And so if I rotate it so that the paper, actually I moved, let me just make sure I'm in the right position. I'm going to put P here. No, that doesn't fit. Let me try to get it so it fits nicely on the paper. Let me put it right here. Okay, that fits. Nope. I'll move it over a little bit. Let's do it here. Okay, so this is my duck here. Here is point P. I know there's all this extra stuff I didn't want. So if yours isn't fitting so good, this is just for this example. Now when I turn my paper, it kind of fits in that box. If you don't care to have it fit in the box so you can go anywhere else, then the P doesn't really matter. Okay, so what it's doing is it's keeping my point fixed at that point, and then I'm rotating it a certain number of degrees. So every time you turn your paper from one direction, like the one orientation when it's horizontal, and then you make it so that it's vertical with this point fixed right here, that is 90 degrees, okay? So what I just did was I moved my paper, it was like this, I'm moving it 90 degrees. This way is clockwise, right? It's going from like 3 o'clock to like 6 o'clock essentially, if I think about where it's going. So then I would actually try to trace as whatever the diagram is here. I'm going to just trace this as best I can. And it's okay if it's not perfect. It's okay if you're not using your tracing paper. You can just draw a sideways duck. Right, something like this, and put a little eye. Okay? It's okay if it's not perfect. It's just to show you that when you do a rotation, depending on how many degrees is telling us, we're going to write down that we just did a 90-degree rotation because I turned my paper one time. Now let's say I didn't want to do 90 degrees. Let's say I'm going to keep it here, right there, and I want to do 180. Then I would turn my paper once, that's 90, and then one more time, and then that would be 180. It's like an upside down duck at that point. And then you're going to go one more time, that's 270 degrees, and back is 360 again. Okay, so we're only doing it in multiples of 90, and then again you have to know, should I go clockwise or counterclockwise? We just moved clockwise because we moved it down to the right. So when I write down what I did here, I would write down that I did a 90-degree clockwise. The abbreviation for clockwise is just CW. If you're doing counterclockwise, it's CCW. Okay, so clockwise, we're moving this, and then we want to say rotation about point P. So notice all the detail there. All we had to do was just say what type of rotation it was, but we had to include all of that detail. So we said how many degrees it was, since we turned our paper just one time, and we had to say what the about which point, and we had to also say clockwise. 3 things that you want to include there: degree, clockwise or counterclockwise, and about which point. Rotation will obviously always be there if that's what's happening. Okay, so we're going to practice this now on our examples where we're not going to have tracing paper. We're going to have to do this without the tracing paper now. Okay, so let's see what to do here. It's asking me for the first one to rotate segment AB 90 degrees about the origin. Notice it never says clockwise or counterclockwise. So if you think back right up here, it said, remember, if the direction is not specified, it's counterclockwise. So we need to move this one counterclockwise. That means think of the opposite direction of a clock. 90 degrees, that means if you turn your paper, if it is vertical, you're going to turn it horizontal. Right? You're just turning it one time to the left because that's counterclockwise. So that's what we're about to do. Before we do that, make sure you identify what point you're doing your rotation about. In this case, it's the origin. So go ahead and plot that point. So you're going to start by plotting whatever point is the where you're doing the rotation about. Okay, so now you don't have to actually like put your pen or pencil on it or anything. You're just going to now rotate your paper, like physically rotate your entire paper, whether it's a quiz, a test, a homework, whatever. On our notes, we're going to rotate it 90 degrees. So instead of it being upright like this, we're turning it towards the left so that it turns on its side like this. That's counterclockwise, 90 degrees, right? And as we do that, we're going to actually write stuff kind of sideways. We're going to write it normal here so that when I turn it, it is going to be sideways. And that's okay. Okay, so here's what we're going to write down. We are going to write down where the positions of A prime and B prime will go based off this same origin. Okay, so what you're going to do is in words or symbols, you're going to write down how you got from 0, 0 to each of these points. So like to get to A from 0, 0, I have to go left 3 and up 1. It's not exactly slope, so don't confuse that with the reflection stuff. We're not talking about slope anymore. We're just trying to talk about location. How do I get there from this origin? Okay, so that's how I would do A prime. For B prime, we would go right 5 and up 2. Okay, so you're just saying the direction that you're going left or right and the direction that you're going up or down with how many units for each one, and that's how you would, get there. So just double check your work. If you count right 5 and up 2, you get to B. If you count left 3 and up 1, we get to A. As soon as you're done writing that, turn your paper back to where it was. Okay, and now we need to plot our actual points so we can see where this reflection actually goes. So from this same point, which was the origin, you're going to go left 3, up 1. So count left 3, up 1, and plot your new point as A prime, because that's what we told ourselves we were going to do. Okay, do the same thing with B prime. You're going to go right 5 and up 2 to plot B prime, and that would be its coordinate. Now, I like to write the coordinates down because sometimes on a homework or quiz or test it may say, like, what are the coordinates? And so it's just good practice. When you write the coordinates, make sure you're always just writing normal coordinates based off the origin. Even if the origin was not the actual center of rotation, on this one it was, but we're about to see on the next one it's not going to be. And then you just connect it with a segment and you're all done with the rotation. So we just rotated segment AB 90 degrees about the origin. And it was counterclockwise since that's what it said. Okay, that's how you would do this. And we're going to try one more, and then you can try a couple on homework as well. Tomorrow we're going to practice this a lot as well. So here's another one. First thing you always want to do, though, and this is where you could make a mistake if you don't do this, take that point and plot it first, immediately. As soon as you start the problem, before you start rotating your paper, don't try to forget to plot that point because it's important. That's where your answers are based off of. So -2, -1, that's my point. And you don't have to label it with any kind of letter or anything. Just know that that's that center of rotation. That's important. Okay, now we have to rotate our paper 180 degrees. Again, it doesn't say clockwise or counterclockwise, but something is special about 180. What's so special about it? It wouldn't matter, right? If you did one turn and another turn and you were upside down like this, right? And then I went back. If I went this way, one turn, another turn, I'm still upside down. So 180 is one of those ones that it doesn't matter what direction it tells us. It doesn't have to because you get there both ways. Okay, so we do need to do it twice, right? Turn our paper twice so it is upside down like this. And then again, you're writing down what happens to A so that it turns into A prime, what's going to happen to B so it turns into B prime. And I like to use words, and you're going to find that I know sometimes it gets tedious to write stuff down. You can abbreviate stuff. You can do L for left, U for up, stuff like that. Some people have used arrows, though I'm telling just be careful with arrows because how you draw your arrows here and then you rotate your paper, that's going to change the direction of your arrows, of course. So be careful with that. Or you can write coordinates. The only problem with writing coordinates down is you're about to see on this one. Because we didn't do it from the origin, our coordinates are not going to be the same coordinates. Like when I say I'm going to move right or left or up or down, that's not the actual coordinate. My final coordinate is not the same. So that's why I like to write with words. So from this point to go to A, you're always going to measure from the point going to A or B. You're not going to measure from the actual segment going to the point. Okay, so we're going left, 1, 2, 3, and down, 1, 2, 3, 4. And it doesn't matter which one you write first, the down first or the left first. It's not slope. It's not like rise over run. We're just writing down the location. Same thing for B. We're going left, 1, 2, 3, 4. And up, 1, 2, 3, 4. Okay, so left 3, down 4, left 4, up 4. And so now we're going to go back to kind of facing it normal. I know it's upside down, so if you're ever confused about like what you wrote, just turn your paper back over. But we need to plot from this point. Now this is the most important part. I know the origin still exists, but we are not caring about the origin. We want to go to -2, -1, and go left 3 and up, down 4. And there's A prime. From that same point that I was measuring my location from, that's where I'm going to plot it from. Same thing for B prime. You need to go left 4 and up 4. So the segment ends up being like this segment here where it kind of like switches A prime, or like A and B kind of flipped because it was a full 180 degrees that it ends up kind of switching spots there. But if you were asked about the coordinates, so if someone said, can you tell me what your coordinates are for A prime and B prime? Now you have to write down just normal coordinates, the way you've learned back since like middle school, where you're going to say I'm going -6 and up to 3. So this would be -6, 3. This one would be a -5, -5. Right? Sometimes they'll ask us for coordinates. So you want to make sure you know how to write the coordinate just from the normal location. Don't base it off of this location or like how you got there. Once your points are plotted and your segment is done, you've already done your rotation. You're just writing down what the coordinates are. Okay, and that's it for